All right, so properties need to be included there, but this should help you when you go back and you look at your lab from last week and you remember the questions that you were struggling on with the properties and that you witnessed in the lab. I want you to always keep in mind when you're asking a question or answering a question or you're trying to address what's going on in an ionic compound, I always want you to think about those electrons transferring. So keep in mind the electrons are moving. Covalent, the atoms are tightly bound together. The nuclei are pretty tight, but there's still room for those clouds that are overlapping to have the electrons holding them together. That's what the bond is, right? Those shared electrons holding those atoms tightly bound together. That's the chemical bond. So let's look at the properties. For ionic, the ions are moving, but not so much in the crystalline solid. Remember, the crystalline solid is this repeating pattern. And in a solid, they're locked. You've got positive, negative, positive, negative. So the crystalline solid actually also has something to do with whether or not it conducts electricity. The electrons don't move as easily through this bound crystalline structure. So ionic compounds conduct electricity when they're melted or if you put them into solution. When you put them into solution, if the salt is the solute, what's the solvent? Water, good. So you got to remember the solute is what we're talking about when we're talking about the ionic compound. The solvent is almost always water, but not always. We're going to talk about that with solubility. Ionic compounds melt at very high temperatures, and the reason why is that positive and negative attraction. It's really hard to break up that positive-negative attraction between the ions. Thereby, it's hard to break them apart so that they become a liquid. The salt that you guys tried to heat in the test tube, it melts at around 800 degrees Celsius. And it becomes a gas, the boiling point, it becomes a gas at 2400 degrees Celsius. That's really freaking hot. So conducting electricity, yes, as long as it's in a melted state, or if it's in solution, you should have gotten that light bulb to light up. Soluble in water, but not so much in polar substances. I'll give you a quick little snapshot of polarity here in a minute, polar versus non-polar compounds. But when you put an ionic substance into water, it should dissolve. But when you put it into things like oil, which is non-polar, it didn't dissolve very well. Agreed? All right, so let's take a look at covalent. Remember, they're tightly bound. The electrons are not escaping the molecule or transferring from one part to the next, where we have positive and negative here. They're going between the nuclei of those involved in the bond. And so what you'll see is that you can see pretty much any state of matter in the molecules. You'll see solid covalent compounds, liquid covalent compounds, gas covalent compounds, because there's a sharing of electrons and they are pretty easily existing in all three states of matter. They have lower melting points and boiling points because while the atoms are tightly bound, the molecules themselves are not attracted to each other very much. Not like they are with the positive and the negative charges over in the ionic. These molecules, like a sugar molecule and another sugar molecule, when they're in the solid state, they're not as attracted to each other like the ionic compounds are. That's why they're easier to melt and easier to boil. You saw how easy it was to melt them, correct? You guys burned some of them, as a matter of fact. You took it through solid liquid and it started escaping into gas and actually heated it up so much that you had a chemical reaction that made it caramel, which is an actual chemical reaction. That's why you saw a color change for that. So these are pretty low temperatures. Poor conductor. Did anyone get the light bulb to light up? Okay, if you did, I would guess it used tap water, because tap water will conduct electricity. You might have forgotten to use distilled water. If you used distilled water and sugar, then maybe your beaker was dirty. There had to have been some sort of contaminant, because sugar should not have been a good conductor of electricity, and you shouldn't have gotten that light bulb to light up. The last thing is sugar. Many of them are soluble in oil, but sugar wasn't that great at it. Would you agree that when you put the sugar in there, it wasn't that great at dissolving in the oil?
Yes.
Some of it did, but not very much. But they're really good But sugar is better in water than some of the other covalent compounds. A lot of covalent compounds will not dissolve in water, believe it or not. But you used sugar as your covalent compound, and that does dissolve a little bit in water. It's just not as great of a, it doesn't go into solution as great as the salt does. Any questions?